Greetings, Pilgrims. Welcome back to another episode of the Polygon Pilgrimage, and today we are continuing with our Ultimate Battle Royale series. Now, here's where we left off last time with our character being able to move left and right, forward and back. You notice we can't rotate the camera, and we don't have a really good handle on our camera yet. It's just sort of following us blindly, right? So today we are going to be working on our camera controller script. Now, there's a lot to explain with this script, so I'm going to take a rare opportunity here and just provide you the script to download in the link description. But what I'm going to do is explain the script and show you some programming tricks, some ways in which you can customize this, and show you how it works, and we'll make it work together, okay? So sit back, relax, let's go ahead and get started. Now, if I select my player, you'll see that we have our animator, our character controller, and our player controller script. And that's what is allowing us to move around the scene, just like this. But we don't have a handle to our camera yet, so let's go ahead and add that. So I'm going to stop play, and here in the scripts folder, there's cameracontroller.cs. Now, this will be in the download description as well, but if you pull the latest Git repo, it should come in this state. Actually, it will come in the state of this being all complete after I'm done showing it to you here. So it will be in this folder already, but if it's not, if you're following along without Git, you'll be able to download this from a link in the description of the video, okay? So I'm just going to click and drag and drop this onto our player, and there it is. See, there's a ton here. That's why I said there's a lot to explain, but let's go ahead and do a little bit of setup here. So first it needs a follow target. You see here it says none. It's looking for a target to follow, right? So our camera setup here is a little bit like Fortnite, where it's kind of over the shoulder. So let's go ahead and create an object underneath our player. So I'm going to right click on the player and say create empty. And that just puts an empty game object down here. And we're going to name this follow target. Now, the position of this needs to be kind of over our shoulder and just a little bit back. So I'm going to set its position here on the X to 0.5. Sorry, 0.5, not 0.05. On the Y is 1.75. And on the Z to be negative 0.15. And you'll see when I tab out of that, so now it's right over my shoulder and just a little bit back like we need it to be. Perfect. So now if I go to my player, and I'm going to click and drag, follow target, and drop it right here on follow target. And now the follow camera target, which is a little bit of a misnomer, it's the camera that is working with the follow target stuff. That's going to just be our player camera, so we're going to put that there. Okay, and now if I hit play, it's going to mostly work. So you'll see I can turn now with the mouse, and I can run around, and the camera follows me around. Now we do have one issue that we're going to solve in just a moment, but if I walk up to these cubes and I rotate the camera, you see how we can get blocked, right? We can't see our character. Well, there's actually code to handle that. We just don't have it set up here yet. So I'm going to change it and show you it working. So if I change this to default, now if I come up here and do this, you'll see the camera will pop. So when the camera gets occluded, it'll pop forward to a point where it has calculated to say now the player can see again, right? So we're going to talk about how that works in the code in just a moment. And then we'll talk about all these settings and how you can adjust them and how you can create some of these cool things like the ability to slide, your turn speed, that kind of stuff. So we're going to talk about that next, but just know that these are all the settings you need to just make it work. Now, for the rest of everybody who's interested in how it works, we're going to go ahead and jump into that, okay? Also notice that when I stopped play, it did not save that, so you need to change that here to default. And later we're actually going to make a new layer and use that anyway. So we should have, we'll be able to add a layer, and we'll do that later. Okay, so let's go ahead and take a look at the script. If I pull up the script, again, there's a lot to get through here, so that's why I provide you the script, and I'm just going to explain it rather than go through and type it out with you like I normally do, which I really like, but I want to make sure that we explain everything. So, at the beginning, everything here you see on the screen, all the way down to line 32 here, this is all just our variables and our settings, okay? So, it looks big and scary and complicated, lots of numbers, but don't worry about it. It's really just all the settings. If you're not familiar, if we look back at our script here in the inspector, you see how this follow targets, camera angles, camera movement, and clipping detection are all bold, because these are section headers, right? So you can create those yourself anywhere in the code you want. Right here, this is the syntax. Open bracket, header, just like that, capital H, open parentheses, open quotations, whatever you want it to be called, and then close everything up on the other end. So quotations, parentheses, bracket. So as an example, I could say, these are the follow targets, right? And if I save that script and then go back, you'll see this update right here. Boop, there it is. So you can name that whatever you want and just come up with those. I'm going to change that back just because follow targets is sufficient. But just you can create your own headers that way. Nice way to organize all of your settings and all of your variables at the top of your script. And you'll see a lot more of that as we go through the series. Next up, we have the two that we have already used, the follow target and the follow cam target. Those are serialized fields, so they're transformed. So that means they're public in the inspector, so we can drag and drop to connect them. And that we'll be able to use those later in the script. Then our camera angles. So there's two things here. We have the rotation speed, which is two values. A vector 2, meaning there's an x value and a y value. So the 2.5f, that is the speed at which the rotation can go left and right and up and down. So you can change those independently if you wish. I like to keep them kind of the same value, just find a value that works. Our pitch clamp is the maximum rotation that we can look up and down. So 70f is the float is the one direction, and minus 11 is the other, so that's how low we can look. So by changing these, you can change that cone of how far you can look up and down. Camera movement. So this is where we get into the range field. I'll talk about range field on this line because it's a little easier. But we have our turn speed and our damp time for the camera. So that's what those are. You notice that the damp time is a very low number, so you want to keep it pretty low. Now the range field, if you're not familiar, you can also create a nice little slider for yourself with the range. So you do that like this, open bracket, range, open parentheses, and you give it a minimum value and a maximum value. And then you go on to still define the variable. So you're just saying, this variable is going to be ranged, but now let me tell you all about it. It's a public float called this, and you give it a default value. And that looks like this in the inspector here. So if we go and look at that, we have here's the value, max camera distance. The default value we've included in the code is 3, but you'll see here this little thing, I can click and drag this. So you can change it kind of visually, which is really nice for some people that want to tweak it. If you're not a programmer, but you're a game designer and you're putting things together and assembling these elements, maybe you want to get in here and be able to kind of tweak it by eye, by hand, and we'll look at this later. We can even tweak this during play and save those settings. But you'll notice here the minimum value we set was 0. The maximum value we set was 100. So there we go. That's what they are. And I'll put it back to 3 for now, just to have it be where its default is. But just know that this is how you create these range fields. So you can click and drag and move it around yourself. Okay, now, next we have 3 variables here that you're not going to see in the inspector, but these are variables that are going to be used in our calculations, okay? So we don't have to worry about them here, but just know that that's what those are. Final section here is our clipping detection. So these are all ranges except for this guy here, and you'll see here that this is they're pretty self-explanatory. The camera collision distance, the camera collision damp rate, the collision return damp time. So you notice again, that's a small value. This is the time it takes to return from that calculated distance change. So we want that to be a small number because you want the camera to kind of snap, so it keeps you in the action. You're not waiting over a second for the camera to kind of catch up to where you are, right? That doesn't make sense. So you want to make sure this is a small value. This is an important field here. So this is our layer mask. We're going to use this in conjunction with our ray casting. And all you need to know for now is this is how you define it, layer mask, and this is what we call it. This is going to be the layer that we tell the camera, hey, if you hit an object that is on this layer, you need to work around those objects, and that's when you need to catch up to the player, right? So then we have our current camera distance, and we have our collision damp velocity. These two change during play based upon the rest of these calculations. So while they're public and you can see them and you can click and drag them, they're really more meant to be public so that you can see what's happening, okay? Now, we are going to instance this script. So at the top, here we have public static instance like we've seen in previous videos so that we can access this instantiation of this script, which should be the only one from any other object. This is going to be very important later on when we do things like ADS and screen effects and that kind of stuff. We want to get to the camera controller. We call camera controller.instance and it will come right to this script. So we instantiate that by, in the awake, saying that instance equals this. So this is the one and only. Now, getting into the different types of update. If you weren't aware, there are 3 kinds of update. There's update, fixed update, and late update. General rule of thumb, and this is not gospel, this is not set in stone, but a good kind of guideline to work off is fixed updates for physics. So fixed for physics, that kind of rhymes. Late update is for camera. So the camera is always kind of catching up to the player, which makes sense. The player wants to do its input first, then the camera catches up. It sounds like the camera is lagging behind, but visually when you see it happen, that's not the case. It's just programmatically, you're talking like milliseconds. Programmatically, it lags so that the player can do their inputs first and the camera can adjust to how it needs to keep the player in focus. Just like if you had a cameraman following you around, right? If you suddenly just start running to the left, the cameraman is going to go, oh, let me turn left and look at them. So they're going to kind of catch up a little bit, and that's okay. But that means that late update, we want to do that. We want the player to do their input first and then the camera to catch up. Okay? And then you have update, which is normal update, normal tick. So really quickly going through these, in the fixed update for our physics, we're essentially creating a new type of rotation for ourselves. We're going to say, hey, take this variable called yaw camera. I'm going to get the camera's transform rotation Euler angle is y. Okay, that's a lot of gobbledygook. What does that mean? So if you're not familiar with the way axes work, is rotating about an axis means if I rotate on the y-axis, I'm actually rotating left and right in the world. So you can see that by when we rotate the character through space, you'll actually see the y rotation change. So if I go ahead and hit play really quick, and if we rotate around, and I'm just moving the mouse left and right, and look what's happening up here. My y value is changing in my rotation. So imagine there's like a pole running from the ground through my character's head. That's the y-axis. So imagine if you attach something to that pole. What's the only way you could rotate something attached to that pole? Is left and right, right? So that makes sense. That's how you think about it. Is think about whatever the axis is, and now I'm rotating based upon a different axis doing this. Whatever that axis is, just draw that pole and then rotate. How can you rotate all along that pole? So it'd be like this little ring object with a thing sticking off of it. How does that rotate? So for the y, we have to go left and right. For the x, it's like there's a line going in his left side and out his right side, and I'm rotating about that. Okay? So that's kind of a way to think about it, is which direction am I rotating? Think of those poles, those invisible poles, and you rotate it along those. Along those. That's the word, Matt. Okay, so that being the case, this makes more sense now, right? My variable here is the camera's y axis. Get the rotation. Euler angles means I want the actual angle. I don't want, I don't want the theoretical angle. I want the actual angle you see there. So then say, okay, take my transform, which is the transform of this camera controller, the object, and say, hey, quaternion slurp. So a lerp is a linear interpolation. Go from A to B over time. Slurp is do the same thing but make it smooth. Okay, so a smooth linear interpolation between two, typically used by quaternions, by rotations, that kind of thing. So quaternion slurp, move from where we currently are, current rotation, to this rotation that I'm theorizing. So it's quaternion.Euler, 0 on the x, make no changes on the x, change the y to this variable I just saved, and change the z to no change on the z. And do so by time.fixed delta time, multiplied by our turn speed. So if our movement is normally 1 and my turn speed is 3, it's 3 times that amount, that kind of thing. That's how you make it go faster or slower. So that's all it's doing. It's saying get my current rotation and then slurp between there and this new one, between where I am currently and where this one should be based upon the turn speed and, fixed delta time. So that's all it's doing, constantly updating, slurping between one position to the next. So next, in our late update, this is where, again, we do all the camera stuff. This is where we're going to be doing the collision detection and getting information from the mouse and all that. So this first part's a little complicated, not complicated. It's simple, but it's confusing because we're going back and forth. So what I'm doing is I'm saying my new rotation, which is a vector 2, meaning it has 2 values, an x value and a y value. Okay, these are the correct terms. So I'm going to use the correct terms and hopefully it'll make sense. So our new rotation is a vector 2, so x and y. And it's saying, hey, the y value, the second value for that, I want to add and equal to that, the input from the mouse x. Mouse x is left and right, okay? And I want to multiply that by the rotation speed y. Okay, so what we're saying is the speed at which I want you to be able to rotate get the mouse rotation, remember left and right, that's what we want to rotate, and multiply that by this value, and then plus equal that to my new rotation. So I'm getting my new rotation's y value essentially, but I'm using the mouse x because that's the left and right, because remember, the y, we're rotating about that up and down pole. Now the x here for new rotation is a minus equals, I know it's a little confusing, but it has to be a minus equals the mouse y, which is up and down, okay? And the minus equals is because the way cameras normally work, unless we allow them to invert, is, if you move up and down, and if you don't do that, then it will be, the opposite. It's like airplane controls. You look up and you look down. You move the mouse up, rather, you look down. So this just keeps it all normal, okay? So minus equals mouse y times rotation speed dot x, because it's that first value. So it's a little confusing that the x doesn't really mean x versus y. It means first value, second value. So then we're going to say, okay, now do a math f clamp, meaning a clamp says take whatever the value is, and I have a minimum and a maximum. You can't go below this, you can't go above this. Whatever the value is, if it's within that range, you're all good. I don't care. If you're outside of that range, I'm going to clamp you, bring you back to one of those two values. So if it goes below the minimum, it sets it to the minimum. If it goes above the maximum, it sets it to the maximum. So we're just going to say, go ahead and clamp that based upon, remember the pitch we talked about? That's that up and down looking rotation, because we're rotating about that x-axis, which goes through our chest, right? From left to right. We're going to rotate, and we're going to say, hey, you can't go above or below those values because that's what we set. Okay. Then our overall rotation is we're going to smoothly damp between our current rotation and this new rotation. That's what we've been defining all along right here. So where are we currently? Where do we want to go? We want to go to here. Okay, do that smoothly. That's what this line is telling us to do. Awesome. Then we finally say, okay, now go ahead and set the rotation. Our Euler angles, go ahead and set it to that value now that we've done it. So this is all figuring it out. This is saying smoothly find a value really that is a smooth transition between the two, where I am and where I want to go. And this says, okay, finally actually apply that to the camera. Okay, this line we're not going to use just yet, but this is here for future reference. Our head value is going to be the point between our follow target and our camera position. Okay, so we're just going to minus those two and get a midpoint. And that's where our head is going to be. Okay, now let's get into the physics stuff. So we're doing raycast. So raycast is like a laser pointer. You press a button, shoots a laser, and the point at which it hits the wall, floor, cat, whatever you're pointing it at, right? That exact point we're going to store as this variable called hit. Okay? And this is how you define it. It's a raycast hit, just like that. Raycast, capital H hit. And we just call it hit for short. In all the tutorials, you'll see it like that too. So this is, we're going to go between our camera and our character. We're going to say, hey, we're going to shoot this ray out. And if we hit something, we're going to make adjustments, okay? So the first line says, shoot a ray out from our follow target position, that thing over our shoulder. And we're going to start there and see if we look at our raycast here. It says origin, direction. So the direction is between the camera position and our target position normalized. So this means we minus those two things together and kind of average together a little bit and say, now normalize, make it kind of a 0 to 1 number and say, what's the direction that this is going in if you were to go that direction. So two people on the street, draw a line between them. Now, if you were to draw that line theoretically forever past them, that's the direction that you would be going between those two people, right? That's kind of what we're doing here with our camera target and our follow target. Then we're saying store that information out into our hit variable that we stored up here. And how far do we want to go? We want to go our maximum camera distance. And what layer do we want to do this on? Because you can do this on layers. You can say a layer that's only for characters, right? So I can shoot a ray. It'll go straight through walls until it hits a player, until it hits a character, pardon me. So we're saying, hey, what is the layer? And our layer, remember, is going to be things that are not the player, that are not UI and everything. So things that are more like our physical environment. That's what we want to hit. So that's what we will change this variable to later on. So once we get all that information, we're going to pass it into this function, which is down here. We'll get to that in a second. Now, else, if this doesn't happen, but also we want to say if we shoot a ray and we shoot a ray camera target up, so it's up vector, and we go up to F, just some distance, right? If we hit something, also send that information. So this, I believe the dot up is up in the world from that position, so from our camera target. So this is for like going through a doorway kind of thing, going into a building. If we go up and we hit something too far, we're also going to do this and say we need to come down a little bit. We need to make those adjustments, right? Okay, and else, so if none of these happen, else, just get our current camera distance and we're going to set it equal to a smooth damp between where we are and our maximum distance. And then don't worry about this. Ref is a collision damp velocity, meaning what's the velocity you want me to use for that? And remember, the return damp time, we want this to be a low number because we want to say, hey, when you make that change, do it quickly because we want to get back into the action. Then finally, after we've done all this, we're going to say the position of my follow target is equal to, and we're going to do this math here. We're going to say get the follow target position minus the camera forward times the current camera distance. So we're going to average all that together, and then that's going to be our current position. Cool. Okay, now remember here we were saying if we do hit stuff, what do we do? So if we do hit stuff, we're going to come here, and we're going to say, hey, our current camera distance is going to be a lerp between our current distance and the point in which we hit, because we want to go a distance, right? So we want to go between our current distance, where we hit that exact point. So vector3.distance is give me the distance between A and B, right? So A is the actual point at which the laser pointer stopped and the position in which the follow target is, right? So we want to go between, this is confusing, our current camera distance wants to be between those 2 points. And then here we're saying lerp, and the time is our damp rate, remember that low value, times time to delta time. So make that change quickly between where we are and where we hit so that we can get past that obstruction so we can see again, right? And then when we're done, we're just going to say, hey, set our velocity to 0 to reset for the next time we do this. And that's it. So this last part here, we're not using this yet, but this will come in handy when we do things like ADS and that sort of stuff in the future. So I left this in here as part of the code. So set target, you just pass it a target transform, and it will set our follow target to that target. So that thing over our shoulder. So when we zoom in, right, when we aim down the sights, we want to change that so we can pass in a new spot to look at. And then when we stop ADSing, we can pass back in the same target again and go back to where we were. Okay, so that was a lot of explanation. Sorry, I just want to make sure that it's clear. So let's go back here and let's see it all in action now. So now we can see what's happening. You know what these numbers mean. It's nice and simple. We run around. And then when I get close to a box here and I look too close to the box, boom, there's that calculation. That if else is saying, hey, my laser pointer hit something. That's not good. Let me go through that to a point now back to where I can actually see my character again. So that is super handy. And you can see that changing here as I do this. Now, one last thing I wanted to explain is we should create our own layer for this. So I'm going to say layer, add layer, and let's call this environment. Environment. There you go. And now I'm going to click on my environment here, which is all the physical things in the world, and say, set it to that. There we go. And now go back to my player script, and I'm going to change this to say environment and not default. And now let's double check it. Should be good still. Run over here. Take a look at our cube. And boom. Yep. So as we get too close, it goes right through. So now that's only going to be affected by physical things in the world, anything on that environment layer. So if you put like a floating UI kind of thing, it won't do that. So if it's, say, like a hologram is transparent, we can see through it anyway. We don't need to worry about that. So we don't want the camera to kind of be fooled by that and be stopped by that. So we don't have to worry about that. So just things that are physical, like cars, trucks, buildings, whatever. If I'm behind this wall and I move this, I want to be able to shoot at that guy. But if I move my camera too much, it'll pop through it to help me see that. Now, one last thing is you can change these values at runtime. So I'm currently playing the game, and I can change these values. So things like my maximum camera distance, I can change that. See, look at that. We can get like really far out if you wanted to, say, as an example. And now if I stop play, you'll notice everything snaps back. So now if I hit play again, and I'm running around and go, oh man, I lost those values, right? So while you're playing and you make adjustments to this, so I'm going to make adjustments to there, adjustments to that, adjustments to this, and say I'm happy with these settings, right? I've tweaked all these settings and I'm really happy with how it's looking. Everything looks great. What you can do is here on your script, over here, the little 3 ellipses, click that and say copy component. Now, when you stop play, yes, it's all going to snap back, but now you can click on the ellipses again and notice you have here paste component values. And if I click that, it pastes everything about this script, all the settings I had, back to the way it was when I just copied it. So I do this literally all the time. I'll be working on something and then I'll just tweak it. If you want to move an object, say you're playing the game and I want to move this cube to a certain point, move it, select it, copy it at runtime, paste afterwards, and there you go. Everything is set back exactly the way you wanted it. All good. Okay? So thank you guys so much for joining me. I hope this helped. And I'm sorry we didn't go over the code every single step, but like I said, there was just a ton of stuff to do today. See, it even works at that distance. A ton of stuff to do today, and I wanted to make sure that I took the time to explain it because we are doing stuff with like physics and raycasts and, oh my God, what is that, right? So I wanted to make sure that I took the time that we needed to explain it and make sure you guys understand it. Now, next time, we are going to be doing the IK to be able to aim our weapon around. And then after that, we're getting to the point where we're going to start building out the world, building out some of these systems, getting multiple characters into the scene together to start testing out the shooting mechanisms and all that later on. So we're going to really start ramping up from here. And there's a lot going on, but this was foundational. So we need to make sure that this is in play, because if the camera doesn't work, you can't see what you're doing, then what's the point, right? So thank you very much for joining me, for sticking with me. I appreciate it. If you guys have any questions, you need help, please join the Discord and ask in the help channel. And there'll be another video out really soon. I apologize, I had the flu for 2 weeks, so that took a little bit of a hit. But there'll be another video out pretty soon. I already have the IK stuff ready to go. So look forward to that. And as always, guys, keep practicing, get better, and I'll see you next time as the pilgrimage continues.